Para-methylaniline acetic anhydride gives para-methyl acetamide. This para-methyl acetamide react with Br2. It is a ring activating group. At ortho para position takes place, bromine and para substituted is there. Hence, it is substituted at ortho. Then product is ortho bromo para methyl amide. Ortho bromo. Here the option B is para methyl ortho bromo phenyl amide. On hydrolysis, the amide bond breakage taking place and it is converted to amine group. The aniline has orthobromo para methyl, option C. The increasing order of reactivity of the lithium aluminum hydride with following. Acid halide is more readily involved in nucleophilic addition substitution. Hence, option C is more reactive. After acid halide, anhydrides are the more reactive. Next option is D. B is correct one. With NaOCH3, it is elimination reaction. Chlorine is eliminated after you get a positive charge at this carbon, and proton is eliminated from this position and this position also. Due to more withdrawing group, this proton is eliminated fast, then double bond is obtained at near to nitro, option A. It is a elimination reaction and rearrangement also. With NaNO2, the amine group is converted to disonium. After H2SO4, it is eliminated, and this is the position of a carbocation. After that, alkyl group rearrangement like takes place in similar to pencal pencolone, and this methyl is migrated to this position. Hence, this is the positive charged carbon. To that positive charged carbon, OH is there. By the lone addition of lone pair of electron to oxygen to the carbocation, this part is converted to ketone. Answer is B. The amide on basic hydrolysis, breakage of amide bond taking place, and finally this part is added by OH group and this part is added by hydrogen. Total 1, 2, 3, 4, 4 carbons are there. To the 4 carbons, first carbon is acid and fourth position there is a amide group. Hence option A is the correct. 1, 2, 3, 4 carbons with 4 carbons amine. First part is acid. With unsaturation, it is a alcohol and thiol. Thiol is more acidic, involved in electrophilic addition reaction. In electrophilic addition reaction, H plus S minus is added to this position and it is the stable cation because of electron withdrawing effect is the least one, and to the cation S is added. Hence the product is OH is added to terminal side and there is a propyl cyanide part. It is its addition is like anti-Marconi rule. Hence B is correct one. Compound P with HCl filtrated product gives Q and filtrate. Q gives effervescence with NaHCO3 it indicates this is an acid because it gives positive test with NaHCO3. And filtrate NaOH oily liquid R. The R react with the Hinsberg reagent gives a solid soluble NaOH. Soluble NaOH indicates that is a primary amine. Hence, after react with the HCl, it gives an acid and primary amine. Check the options. So, it is on hydrolysis, gives this part is acid and it is a secondary amine, but you get the primary amine, hence it is not correct. For this compound, after hydrolysis, this part is converted to acid and this part is converted to primary amine, hence your option is B. With lithium aluminum hydride, amides are converted to amines. That is a reduction of lithium aluminum hydride. Amide part is converted to amine. This is an amide part converted to amine. And reaction with Br to NaOH. In amide, nitrogen is bonded to aromatic ring due to presence of one lone pair. It acts as a ring activating group. To this ring activating group, electrophilic substituted at ortho and para position, and para is more stable. Hence, option A is the amide part, amide part bonded to para position bromine. So first compound is an amine A, B is an amine, B amine here is the option, and A is the para bromo amide. D is correct one. The isomer of ABC with molecular formula. A and C gives a disonium. It indicates it is a primary amine or aniline group. And B is with sulfonyl chloride insoluble product. Insoluble indicates a secondary amine. By these two observations, A and C are primary, B is secondary. So in that product A, B, C respectively. So in first option, it is a aniline can form disonium salt. Option A is the correct one with respect to disonium, and B also correct one. Prime amine forms a disonium, and C also forms a disonium. D also forms a disonium. And compound B is insoluble in alkali. It must be a secondary amine. So there is no amine group. It is a secondary, and it is also secondary. It is also a secondary. Hence, B, C, D may be. And the consequence reaction is after hydrolysis, primary amine, aromatic amine, it gives the alcohol with hydrolysis. It gives alcohol, and there is a ethyl group at this position, and oxidation with KMnO4, it gives the para-hydroxy benzoic acid. By these two observations, option C respectively primary amine, hence B is correct one. Amides with Br to NaOH Hoffman rearrangement. In Hoffman rearrangement, one carbon is decreasing and they are converting to amine. Amides to amine group. And after heating, it has an ester part. This ester part is substituted by amine group, gives cyclic amide. Cyclic amide. Hence, the option is with the cyclic amide B. C is the correct one. Benzene sulfonyl chloride is Hinsberg reagent. A3. Select A3 option. Here only one is correct. C. Cyanides with methyl magnesium bromide gives a ketone after hydrolysis. This ketone with sodium amalgam Clemmensen reduction gives butane. So the correct option C is butane A. Aniline with bromine water gives 2,4,6 tribromoaniline. 2,4,6 tribromo. It reacts with NaNO2, formation of NaNO2, formation of disonium salt taking place. Aniline is converted to disonium chloride having 2,4,6 tribromo. After react with H3PO2, the disonium chloride part is converted to benzene, which has 2,4,6 tribromo, option C. Aliphatic amine with NaNO2 forms disonium. After hydrolysis, they gives alcohols, option C. In Hoffman degradation, migration of only alkyl group takes place from the carbonyl is wrong option. The migrated Hoffman degradation, the electron deficient atom in the light of the above statement. Choose the most appropriate. In this statement, one is incorrect, statement two is correct. It is based on mechanism. You have to follow the one's mechanism which is dealing in class. With NaCN, the bromide part is substituted to CN group. After that react with base, the acidic proton from this carbon is removed and it is converted to anion and it is substituted to cyclohexanone in compound 2. This part is substituted to here and the product is methoxybenzene having this position cyclohexane and the carbonyl part of the cyclobenzene is converted to alcohol and CN is remains here. CN is remains here. So the structure is CN and this is the OH. And further it react with H2Ni. H2Ni is the cyanide to amine part. Cyanide group is converting to amine. Methoxy is remains as the same and to the methoxy here to the cyclohexane OH group and it is converted to CH2NH2 amine part. In the given option, B is the correct one. Alkyl cyanide with dibol converted to aldehyde, cyanide to aldehyde part. When react with NaHCO3, the compound A on hydrolysis, it produces HCl acid. It liberates carbon dioxide by the combination of NaHCO3. It produces carbon dioxide. A is the correct one. Cyanides on partial hydrolysis initially they gives amide. On excess hydrolysis, the amides are converted to carboxylic acid. Hence, option A is an amide. Cyanides on hydrolysis gives acid. Acid with SOCl2 converted to acid chloride. Acid chloride with rosenmude, palladium barium sulfate gives aldehyde. Finally, it is a propanaldehyde. Option C. Chloroform and base is a isocyanate test. Primary amines are converted to isocyanides. In the given options, there is no isocyanide. All options are wrong one. The isocyanide further react with palladium and hydrogen. Isocyanides converted to secondary amine. Here is the secondary amine. Here is the chloro, not one. It is also a secondary amine. It is also a secondary amine. And here is there is a cyanide. The cyanide part also reduces. Here cyanide not reduced. In this also cyanide not reduced. In this cyanide is reduced to amines. Hence D is correct one. With NaNO2, this part is converted to NaNO2. With NaNO2, this part is converted to disodium, followed by hydrolysis, converted to alcohol. Alcohols on oxidation gives acids. Finally, this part is converting to acid. Acids on ester react with cyclization, gives the compound. Here, acid is treated with H2SO4, formation of acyl port carbocation substituted at this position and this position, but it is an oxygen. This oxygen is an electron releasing group. Electrophilic substitution at ortho and para position taking place, not meta. Hence, cyclization takes place with respect to oxygen at meta position. After hydrolysis, this part is converted to phenolic part or acidic part. In that option C is correct one. With Br2 NaOH, with Br2 NaOH, followed by treatment with gives positive carbyl amine. Positive carbyl amine indicates primary amine. Primary amines with half amine which is given by amide. Initially, the reactant is an amide. This is an amide with Br2NaOH gives to propylamine. Propylamine on carbylamine test gives isocyanide. Hence, the option is C. It is a nitration, electrophilic substitution. To this benzene ketonic part is presented is it is a ring deactivating, less reactive, and to this ring amine part is present, lone pair of the amine involved in delocalization, and this ring is more reactive. With respect to electron releasing, ortho and para position is substituted a nitration. Hence, in ring A, the nitration takes place at para position with respect to amine. So, amine, para position, nitro, no. Amine, no nitro. Amine, metanitro. With respect to amine, NO2 substituted at para. D is correct one. Formaldehyde and HCl gives benzyl chloride. This benzyl chloride, when react with the AgCN, gives isocyanides. In AgCN, nitrogen is the donor, hence it is benzyl isocyanide. First one is benzyl chloride, second one is benzyl isocyanide D. Basic nature of order. It is aliphatic one, aromatic, and it is also aromatic. Aliphatic is more basic, and this aliphatic, aromatic, these two are aromatic. In that aromatic, pyrrole lone pair involved in delocalization, pyridine lone pair not in delocalization. Not in delocalization is more basic, and so 3 is more. After 3, first one, 2 is the least one. X grams of ethylamine. Ethylamine is react with NaNO2 followed by water. Followed by water, it gives ethyl alcohol and evolution of N2 gas. That gas is nitrogen. Based on balanced equation, if it is 1 mole, the ethyl alcohol obtained also 1 mole and dinitrogen produces also 1 mole. For 1 mole of dinitrogen, the gas occupied is 22.4 liter. But as for problem, the given occupied nitrogen is 2.24 liters. 2.24, 22.4 liter, 1 mole indicates 2.24 is a zero point 0.1 mole. For the zero point 0.1 mole, you get the zero point 0.1 mole of nitrogen. The reactant also used is zero point 0.1 mole. And ethyl alcohol, ethyl amine for x grams. For 1 mole of ethyl amine is 45 grams. For zero point 0.4 mole, it is 0.45. Hence, answer may be written as 45 into 10 to the power of minus 1. X is 45 into 10 to the power of minus 1. Then 77 answer is 45. X grams of ethyl X grams of ethylamine subjected to NaNO2 followed by hydrolysis liberated N2 and HCl. The HCl generated was completely neutralized by zero point 0.2 mole of NaOH. When ethylamine subjected to NaNO2, the products are ethyl alcohols N2 and HCl. In this reaction, the reactant is 1 mole and products all are obtained as 1 mole. The obtained HCl react with the completely zero point 0.2 mole of NaOH indicates the HCl product moles is zero point 0.4. For the zero point 0.4 moles of HCl, the X is zero point 0.2 mole. For 1 mole, it is 4.5 ethylamine grams. For zero point 0.2 mole, 45 into zero point 0.2, that is 9 grams. The ethoxy group is ring activating group, and in nitration, it is the orthopara directing group. In orthopara directing group, the nitration taking place at ortho and para. Here, the product is to that nitration ethoxy group, nitration taking place at para nitro, and it is react with Br2 and Fe. With Br2 and Fe, bromination, NO2 is a deactivating group, ethoxy is an activating group. With two bromines, it is substituted to ortho, para, ortho. But para position is already substituted with NO2. Then two bromines are substituted at both ortho to this epoxy, ortho, diortho, and para substituted. And the question is number of oxygen atoms and bromine atoms ratio. In this oxygen atoms, NO2 is 2 oxygen atoms. In ethoxy group, 1 oxygen, total 3 oxygens. And bromine atoms is 2 presented in the compound. Hence, the ratio is 3 by 2. 3 by 2 is 1.4. It may be written as 15 into 10 to the power of minus 1. The number of oxygen atoms and bromine atoms ratio is dash into 10 to the power of minus 1. That is 15 into 10 to the power of minus 1. An amine prepared by ammonolysis of benzyl chloride. So benzyl chloride on ammonolysis gives benzyl amine. This benzyl amine react with para-toluene sulfonyl chloride, and it is a primary amine. Gives the soluble product with NaOH with para-toluene sulfonyl chloride. The product obtained is this one. And total this molecular weight is 287.